Hey guys, today we're looking at section 5.2, which is going to talk about the first derivative test. So when the function is increasing, that means that our derivative is positive. This is because when our function is increasing, so it's increasing right here and over here, that's when our slope is positive, so that's when our derivative is positive. Then when the function is decreasing, the derivative is negative. So same thing, when our function is decreasing, our slope is going to be negative, so our derivative is going to be negative. So it's decreasing there, and it's decreasing here. And then the last one, when the function changes from increasing to decreasing or vice versa, the derivative is going to be 0, or it could be undefined. So that happens at these points right here, which are our critical values, our extrema that we have on our graph. So if you remember back in Unit 4, when we were talking about motion, I introduced this little diagram right here. So that was between the relationship of our position, velocity, and acceleration. But this can be used for any function that you're looking at with its derivative and its second derivative. And then a way, if you don't want to write out the whole table, is you can do f of x, f prime of x, and f double prime of x, and you're going to have a positive, negative, up, down, concave up, concave down. Positive, negative, up, down, and positive, negative. So you follow that same cycle, you just move over 2 places every time that you do it. So that's a really easy diagram that you could draw on your AP test or draw on something somewhere whenever you are taking a test or a quiz. So let's use the table to answer some questions right here. So number 1, the function is decreasing because its derivative is blank. So when my original function is decreasing, my derivative is negative. All right, the next one says the function is concave down because its second derivative is blank. So my original function is concave down over here, and my second derivative is negative. All right, the derivative is blank because the function is concave up. So if I'm looking at my function being concave up, and we're looking at our derivative, that means the derivative is increasing. Notice it said derivative and not second derivative, so make sure you're paying attention to that. The blank is increasing because the derivative is positive. So that means I'm going to look at my derivative. It's positive right here, so that means my original function is increasing. Oh, sorry, it already said increasing. The blank is increasing. The function, the original function, is increasing. Okay, the function has a relative maximum because the derivative changes. So if it has a maximum, that means that we're going from increasing to decreasing. So my derivative is changing from going to be positive to going to be negative. So I'm going to say it changes from positive to negative. And the function has a relative blank because the derivative changes from negative to positive. So its derivative is going from negative to positive. That means that our original function is going, if it's negative, it's going down, and then if it's positive, it's going up. So that means in between those two, it would have a minimum. So those are some examples with how this table can help you when you're looking at these types of questions on the AP test. Now let's come to a different table that we are going to fill in based off of some critical points from this graph. So the critical points on my graph, well, I've got one here at that maximum, one here at that minimum, and one here at our sharp turn maximum. So that's at 3, 5, and 6. So I'm going to put them on my number line. I'm going to have a 3 right here, a 5 right here, and a 6 right here. Notice I lined it up with the lines in my table. So my first interval is everything less than 3, so from negative infinity to 3. Then my second interval is between 3 and 5. Then I'm looking between 5 and 6, and 6 off to infinity. So from negative infinity to 3, my original function is increasing. So I am going to say increasing and draw a little arrow. From 3 to 5, my original function is decreasing. And so I'm going to draw little arrows on the ends that match up because it's going to help us with our conclusions that we're going to draw. So from 5 to 6, it goes back to increasing. And from 6 to infinity, it goes back to decreasing. So we can now make some conclusions about our derivative and about these specific points. So if it's increasing, that means that my derivative is going to be positive. If it's decreasing, that means that my derivative is going to be negative. Increasing means we're going back to positive again. And decreasing, we're back to negative. And I just wrote increasing instead of positive. And negative over here. So the conclusions that I can make, if it goes from increasing to decreasing, or my derivative goes from positive to negative, that means that I'm going to have a maximum at 3 right there. So what I'm going to say is that there is a relative max at x equals 3 because the function changes from increasing to decreasing. And the reason I'm talking about the function is because the graph that they gave us over here is the original function. If they had given me a derivative, my reasoning would be based off of the derivative instead of the original function. So the next thing that I can say is at 5, there's a relative minimum because the function changes from decreasing to increasing. And over here, I'm going to say there's a relative max at x equals 6 because the function changes from increasing to decreasing. Okay, so for this one, they gave us a graph. Let's look at what happens when they just give us an equation, which is what most of your problems that deal with this are going to look like. So our first step is to find the critical points, which we did in our last little video, our last section. So remember, we're going to take our derivative. So f prime of x is equal to 3x squared minus 3x. I'm going to take that derivative and set it equal to 0. So 3x squared minus 3x equals 0. I can take out a 3x. I have x minus 1. So 3x equals 0. X minus 1 equals 0. So x equals 0 over here, and x equals 1 here. So those are my critical points. X is equal to 0 and 1. So I'm going to draw a number line, and I'm going to put those on my number line. So my number line's actually already here, so I'm going to put my 0 right here and my 1 right here. So the intervals that I'm looking at are from negative infinity to 0, 0 to 1, and 1 to infinity. So this time, since I don't have a graph where I can very clearly see if it's positive or negative, or increasing or decreasing, what I'm going to do is I'm going to pick a test value. So if I'm looking from negative infinity to 0, I'm going to pick some number, let's say negative 1, that falls in that interval. Then between 0 and 1, let's do 1/2. And from 1 to infinity, let's do 2. So those are my test values that I'm going to pick. And then, if I took these test values and plugged them back into my original function, there's no way for me to tell if it's increasing or decreasing. But if I plug them into my derivative, it'll tell me if it's positive or negative, which then will tell me if the original function is increasing or decreasing. So I'm going to take these numbers and I'm going to plug them back into my derivative. I'm going to plug them back into that 3x squared minus 3x. So I'm actually going to write it down here. F prime of x is equal to 3x squared minus 3x. So I'm going to write it down there so it's a little bit easier for us to look at the table and the whole thing. So f prime of -1, well, -1 squared is positive, so that would be a 3 minus 3 times -1 makes that positive again. So 3 plus 3 gives me 6, which is a positive number. So if it's a positive number, that means that my f is increasing. And I can say that because f prime of x is greater than 0. So that means that we are increasing right here. Now if I plug in 1/2, 1/2 squared is 1/4, so then I'm looking at 3 over 4 minus 3 over 2. So 3/4 minus 3/2 is going to give me a negative number. So I'm going to say that this is negative. So my function here is decreasing because f prime of x is less than 0. So I'm going to put my arrows that it's decreasing. And if I plug in 2, 2 squared is 4 times 3 is 12. Minus 3 times 2 is 6. 12 minus 6 gives me a positive number, so we are increasing here because f prime of x is greater than 0. So I'm going to have increasing here. So my relative extrema, the conclusion that I can make is, well, here it goes from increasing to decreasing, so I'm going to say that there is a relative max at x equals 0 because, and remember, we're talking about our derivative here, so I'm going to use my derivative in my explanation. So I'm going to say because f prime of x changes from positive to negative. And over here, I can say that I have a minimum, so I'm going to say a relative min at x equals 1 because f prime of x changes from negative to positive. And so what we are going to do is we are now going to sketch our graph. So to get some points to sketch, I know that I'm going to have some type of relative maximum or minimum at 0 and 1. So let's see what happens when I plug 0 into my original function. So if I plug 0 in, I'm at 2. So I can say that I'm going to have the point 0, 2. If I plug 1 in, that means I'm going to have 1 minus 3/2 plus 2. So 3 minus 3/2 would give me 1.5. So I'm going to have a point right here. I know that this one is a maximum, so I know this is going to come up this way. And then this one is a relative min, so it's going to look something like this. There's a sketch of my graph. Okay, so now let's look at some where we don't have the table, because you're not going to be given the table on your test or on the AP test. And we're not going to have to sketch our graph here. We are just going to find our relative extrema for my function. So first thing is to take the derivative. So f prime of x is equal to, I got to do a chain rule here. So I'm going to have 2/3 times x squared minus 4. And 2/3 minus 1 is a negative 1/3. And then I'm going to multiply it by the derivative of the inside, which is just 2x. So f prime of x is equal to, well, 2 times 2x is 4x over 3 times, I'm going to do x squared minus 4 to the 1/3. So there's my derivative. And remember, to find our critical values, we're going to set the top and the bottom equal to 0. So when I set the top equal to 0, I have that 4x equals 0, so x equals 0. When I set the bottom, I have 3 times x squared minus 4 to the 1/3 is equal to 0. So really I'm looking at x squared minus 4 is equal to 0. So x squared is equal to 4, and x is equal to plus or minus 2. So my critical values are 0 and positive or negative 2. So I'm going to draw my number line. I'm going to put it over here. And I'm going to put those points on my number line. So I'm going to have a negative 2, 0, and positive 2. So if I want to pick some test numbers, let's do over here, I'm going to do negative 3, negative 1, 1, and 3. And remember, we're plugging all of these back into our derivative. Okay, so I've got a fraction here. So if I do 4 times negative 3, well, that's going to give me a negative on the top of my fraction. And then if I have down here a negative 3 squared would give me 9 minus 4, which is a positive number. Taking the cubed root of a positive number is still going to give me a positive number, times that 3 would still give me positive. So negative over positive gives me a negative number overall. So my function is going to be decreasing here. Let's do the same thing with negative 1. 4 times negative 1 is a negative number on top of my fraction. Negative 1 squared is going to be a 1. Minus 4 is a negative number, so a cubed root of a negative number is still negative, times the positive, still negative. So a negative over a negative gives me a positive number, and we are increasing here. All right, 1. 4 times 1 is positive. And then 1 squared in that whole bottom fraction is basically the same thing as negative 1 squared, so that's also going to be a negative. A positive over a negative is a negative number, so my function is decreasing here. And let's plug in 3. 4 times 3 is going to be positive with 12. And just like when we had negative 3 here, a negative 3 and 3 squared give me the same thing. So since the bottom of the fraction here was positive, the bottom here will also be positive. Positive over positive gives me a positive number, so we are increasing here. So you can kind of see how our graph makes this kind of like wave shape. So the conclusions that I'm going to say that there is a relative minimum at x is equal to negative 2 and 2. We've got a min here and a minimum here because f prime of x changes from negative to positive. And I can say there's a relative maximum at x equals 0. So I'm going to have a maximum here, and I can say that because f prime of x changes from positive to negative. So I found my relative extrema using my first derivative test. All right, we've got one more we're going to look at. So this one says find the intervals where the function is increasing and decreasing. So I'm going to do the same thing, but instead of finding the extrema, I just need to find the intervals where it's increasing and decreasing. So first step is to take the derivative. So f prime of x is equal to prime 1/2 and minus the derivative of sine x is cosine x. So now I'm going to take that and set it equal to 0. So 1/2 minus cosine x is equal to 0, or 1/2 is equal to cosine x. So we're looking on the interval from 2 to pi, or sorry, 0 to 2 pi. Oh, I'm having a hard time talking today. So where my cosine is 1/2 on that interval from 0 to 2 pi is at pi over 3 and 5 pi over 3. So those are my critical points. So I'm going to put them on a number line. So here's my number line. So I'm going to have my pi over 3 here, and I'm going to have 5 pi over 3 here. But remember, we're only going from 0 to 2 pi. So I need to pick some numbers that are in between 0 and pi over 3, in between pi over 3 and 5 pi over 3, and in between 5 pi over 3 and 2 pi. So what I'm going to do here is, well, in between pi over 3 and 5 pi over 3, we could do pi over 2. And 0 and pi over 3, let's do pi over 6. And over here, between 5 pi over 3 and 2 pi, let's do 11 pi over 6. I guess to make it easier, instead of doing pi over 2 right here, we could do pi, because that's between pi over 3 and 5 pi over 3. So that makes it just a little bit easier. Pi is a pretty easy one to deal with. And remember, we are plugging these into our derivative right here. So if I plug in pi over 6, that means I'm looking at 1/2 minus the cosine of pi over 6, which the cosine of pi over 6, if we are looking at our unit circle, is pi over 6, cosine is square root of 3 over 2. And the square root of 3 over 2, if you look at it as a decimal, it is like 0.866 something, which is bigger than 0.5, so this is going to be negative, which means we are decreasing here. Okay, if I look at pi, I'm going to have 1/2 minus the cosine of pi. Well, my cosine for pi is -1, so 1/2 minus a -1 is going to give me a positive number, so we're going to be increasing here. And 11 pi over 6, so 1/2 minus the cosine of 11 pi over 6. So if I'm looking at 11 pi over 6, the cosine is square root of 3 over 2, which was the same as our pi over 6, so that's also going to be negative, so we're going to be decreasing here. So the conclusions that I'm going to say, I am going to say that f of x is increasing on my interval pi over 3 to 5 pi over 3 because f prime of x was greater than 0, and f of x is decreasing on my interval from 0 to pi over 3 union 5 pi over 3 to 2 pi because f prime of x was less than 0. So that's how you can use your first derivative to determine if something is a minimum or a maximum value, or to determine where your graph is increasing or decreasing. So that is it for this set of notes. You do have a Go formative for homework, so please make sure that you work on that. And remember, if you have any questions, you can come to my tutoring times, send me an email, or just ask me at the beginning of our next class period. So make sure you work on that Go formative, and you guys have a good day.